Welcome to today's podcast, Oil Spill Investigations, evaluating analytical techniques for environmental forensics. Oil spills such as Deepwater Horizon disaster and Malaysia coastal incidents require accurate forensic identification. Today, we explore analytical methods, comparisons, real-world applications, and quantitative analysis. We will cover principles of analytical techniques, critical evaluation, sample preparation, and a quantitative forensic calculation used in source identification. Let's begin with analytical principles, starting with Loo.
Okay, thank you, Chan, for your introduction. So first of all, I'd like to talk about GC-MS. So GC-MS works in two key stages, which include gas chromatography. First separates complex hydrocarbon mixtures into individual components, and then mass spectrometry identifies these compounds based on their mass to charge ratio. And this allows for the detection of stable biomarkers, for example, biopaints and also paints and also sterines, which are highly resistant to environmental weathering. And as demonstrated by Wong, these biomarkers remain relatively unchanged even after prolonged exposure in marine environments, making them highly reliable for source identification in oil spill forensics.
Quite agree with Lou about the GC-MS, but I think the GC-GC-HRMS method also significantly enhanced the analytical capability by introducing the two-dimensional separation, allowing the compounds that overlap in traditional GC-MS to be resolved more clearly. This result is much higher resolution and improve the detection of trace-level compounds in complex mixture. So according to the Alexandrino, this technique is particularly effective in distinguishing the chemically similar GC samples that conventional GC-MS cannot differentiate, highlighting its importance in more advanced forensic investigation.
I think I can agree with both of you. I think from that we can compare that the GC-MS is widely used because it's simple, fast, and also suitable for the routine analysis. However, it might be less accurate for the very complex or weathered oil sample because some compound might be overlap and also reduce the accuracy. And on the other hand, like for the GC-HRMS, provide more detail and also accurate result for the complex sample, but it's more expensive and also difficult to operate. I think to improve this investigation, we can use statistical methods such as the thermometric analysis to compare the data patterns and also help to increase the confidence in matching oil sample.
Thank you. Thank you, Salma. Now let's move on to how these methods are applied in real forensic cases.
Okay, so for in the Deepwater Horizon oil spill, the advanced analytical technique play a crucial role. Among them, like GC-MS or tandem mass spectrometry, improve the detection of trace level biomarkers such as opanes and sterines, even after the extensive environmental weathering with rain, sunlight, and micro biodegradation. So to overcome this limitation by offering higher sensitivity and selectivity compared to conventional GC-MS. So this allows scientists to accurately track weathering pattern over time and still match degraded oil residue back to the original. So as a result, it strengthens the reliability of forensic conclusion and provide a robust scientific evidence in legal and environmental assessment. So that's
Thank you, Tan.
GC-MS.
Thank you for sharing, Adain. So I'm very agree to you. So while GC-MS remains the global standard in oil spill forensic due to its reliability, availability, and also well-established protocols, it does have some limitations when dealing with highly complex or weathered samples. So in order to enhance the analytical accuracy, it's often combined with more advanced techniques. For example, GC times GC-HRMS, which provides two-dimensional separation and ultra-high resolution for complex hydrocarbon mixtures. And this also allows for better compound separation and identification, especially when overlapping peaks occur in validating results by comparing large datasets and in the GC-MS. And in addition, statistical tools, for example, chemometrics, play a very vital role in validating results by comparing large datasets and also identifying patterns that may not be visible through manual interpretation. And also by integrating these approaches, scientists can achieve a higher confidence in source identification, reduce uncertainty, and most importantly, produce more defensible forensic evidence. How you guys thought about that?
Yeah, I think I agree with Lou and Daen mentioned before. Each technique in oil spill investigation has its own strengths and also limitations. For the GC-MS, it's widely used because it's practical, affordable, and also reliable, but it has limitations with the complex sample. For the GC-GC-HRMS, provide more detail and also accurate result, although it's more expensive and also require the expert handling. For the statistical methods also help to reduce the error and also improve the confidence in identifying for the oil source. Therefore, by combining this three techniques will give more accurate and also reliable investigation result.
Very interesting, the sharing, and I will share some things that I read before about the article titled "The Deepwater Horizon and the Exxon Valdez Oil Spill and also the Prestige Oil Spill demonstrate how advanced the analytical chemistry is used to identify the oil source and support the legal and environmental investigation." So in the Deepwater Horizon case, the GC-MS biomarker fingerprinting, the GC-GC-HRMS, and also the GC-MS and the chemometrics were used to track the oil weathering in the seawater over time and monitor chemical degradation after this disposal use, ultimately providing the strong forensic evidence for the spill, fate, and liability.
I agree with Go actually. Similarly, the Exxon Valdez spill relied on GC-MS biomarker fingerprinting, PAH profiling, and hydrocarbon ratio analysis to confirm the tanker as spill source, establish biomarker fingerprints such as hopans and sterans in cord, and demonstrate long-term persistence of oil in sediments. In the Prestige spill, GC-MS fingerprinting, alkane and biomarker ratio analysis, and multivariate statistical matching were applied to distinguish the Prestige oil from other Atlantic crude sources. Determine transatlantic transport pathways and also support environmental liability assessment across Europe.
Okay, thank you. So just now, Gu and also Chef has shared some of the cases happened before. So in addition, the Hebei spirit spill case, Brazil mystery oil spill, and also Sarnia oil spill case has highlighted how the fingerprinting supports both environmental monitoring and also regulatory enforcement. And in the Hebei spirit case, GC-MS biomarkers fingerprinting, PAH pattern comparison, and also weathering correction models were used to identify the tanker collision as the source, differentiate spilled crude oil from coastal background hydrocarbons, and also provide legally admissible forensic evidence. Thank you.
I think based on the Loo stated before, right? In Brazil, Mr. Oil spill case, scientists used the GC-MS, also high resolution mass spectrometry, and also the statistical analysis to compare the unknown oil sample with the global database. This method helped to identify the oil source and also connect the different coastal spill to the same petroleum source. Meanwhile, the Sarina spill in Canada, they used GC-MS fingerprinting and also the hydrocarbon analysis to identify the industrial oil source and also separate spill oil from the refinery contamination and also support the legal enforcement actions.
Thank you very much, Salma. These real cases demonstrate that forensic oil analysis is essential for legal enforcement, environmental damage assessment, and corporate accountability. We'll move on to Chef, who will explain sample preparation.
Yeah, actually, the sample preparation is a very interesting process and it begins with a very careful preparation. Yeah, so the first step is samples are collected in a clean glass containers, so to avoid any contamination. Then the hydrocarbon are extracted using a dichloromethane, which effectively dissolves petroleum compounds from environmental matrices. And then the extract is concentrated to enrich the targeted hydrocarbons, followed by silica gel cleanup to remove any impurities such as sulfur compounds and natural organic matter. Yeah, in tropical environments like Malaysia especially, where high organic content from sediments and mangrove can interfere with the analysis. Additional filtration or pre-cleaning steps are often required. Yeah, this ensures the clearer chromatographic signals for GC-MS biomarker fingerprinting, which is widely used in real-world spill investigations, such as mentioned before Hebei spirit, where accurate source identification depends heavily on the clean and well-prepared samples.
Okay, now to calculate the quantitative elements, we assume that hopans are a stable hydrocarbon biomarker. They are commonly used in oil spill forensic because they remain relatively unchanged even after weathering. So in this calculation, the spill sample has a biomarker peak value around 0.85, while the reference oil has a value of 0.8. So we divide 0.85 by 0.8, we're giving the hopan ratio of 1.0625. Where the value close to 0, this indicate that both samples have very similar biomarker composition. So therefore, that's why the hopan is widely used to support oil spill sources. So for calculate the relative percent difference, which is RPD, we use the formula. So when we use the formula, we get the RPD is around 6.06%. Since the RPD is below than 10%, so this match between the spill sample and reference oil is considered acceptable. So this in environmental forensic analysis, an RPD below 10% is generally considered acceptable. Therefore, this result statistically confirm that the spill sample closely match the reference oil sources.
Thank you very much, Daen. So now I will go on to a conclusion. Oil spill forensics relies on the integration of multiple analytical and statistical methods to achieve reliable and defensible results. Techniques such as GC-MS, GC HRMS work together to separate, identify, and compare complex hydrocarbon mixtures with high precision. This combined approach is especially important when dealing with weathered or mixed oil samples where a single method may not be sufficient. From the Deepwater Horizon oil spill to Sarnia spill in Canada, these advanced forensic techniques have been essential in identifying pollution sources, supporting legal accountability, and guiding environmental remediation efforts. Ultimately, the integration of scientific methods ensures accurate environmental accountability and strengthens our ability to protect marine ecosystems. That's all from us. Thank you very much.